Hello everyone, welcome to the Sunrise Ground Audio Lab. I'm Sheersh, researcher in the Department of Climate and Space Sciences at University of Michigan, and I'll be hosting you for this section. So let's get started with this training module. Our Sunrise GRL program is in collaboration with Sunrise Space Mission and Radio Jove program. I really acknowledge my team and NASA funding grants to make this project possible. So training module section 3 is all about the analysis of solar radio burst that you have observed from your installed radio antennas. And in this particular training module 3.1, I'm going to discuss about the solar radio burst identification. As I already mentioned in previous modules, here I'm again sharing the prerequisites understanding, which includes basic high school science, high school reading comprehension, speed, wavelength and frequency of waves, electromagnetic wave spectrum, graphical interpretation of data, and I'm very sure that you have already gone through training modules 0, 1 and 2. So in this training module, we are going to learn about how to analyze observational data to identify emission mechanism, solar dynamic spectra observed from Sunrise GRL, classification of radio burst type, the factors which influence the solar radio burst, and significance of the solar radio burst in solar physics research. I'm very sure that you must be familiar with these images. At the background, you are seeing Sunrise GRL antenna setup, and this top image is a dynamic spectra of solar radio burst. So here in y-axis you are seeing different frequency ranges over time, and these color bars are showing the different intensity of solar radio burst. So here I'm going to show you how to identify different type of solar radio burst. So if you have gone through training module 0 and 1, you must be familiar with the different type of solar activities and solar dynamic spectra. So now if you think about any solar activity, let's suppose solar flare. Solar flares are the sudden release of stored magnetic radiation. We get a sudden brightening and a release of energetic particles with the flares. In this video, you can see this brightening as a flare, and CME is blowing away from the sun. So what happens usually, if you look at the radiation or radio emission, once we get the sudden release of electromagnetic radiation, this is also accompanied by the fast electron beam. So the very first signature they produce as a type 3 radio burst. So here I'm going to explain you how to look at the many frequencies, high to low, over the time. So this is known as dynamic spectra, and every now and then we can see different shapes which can be classified as a different type of solar radio burst. So this frequency range or the frequency axis is simply a measure of height above the solar surface. So lower the frequency, it means you are at the higher height of the solar surface. So these signatures, as here you can see the different shapes. So very first is the vertical line, which is known as type 3 solar radio burst, and it is associated with solar flare. After that you can see the some fuzzy signature, which is known as type 5 solar radio burst. A bented structure known as type 2 solar radio burst, and they are associated with CMEs, and a very fuzzy signature which is covering almost a wide range of frequency, which is known as type 1 solar radio burst, and a very dense but at the higher frequency ranges, these signatures known as type 4 radio burst. How these signatures are related with the different solar activities, I'll explain in the next module. So along with this cartoon image of solar dynamic spectra, here I'm going to show you some real observation of different type of solar radio burst. So this bottom image, you can see a very good example of type 3 solar radio burst. Here you can see a vertical bright line which covers the wide range of frequency, which is associated with the solar flare, and shows that we get a sudden release of electromagnetic radiation with the flares. In the second image here, you can see the drift of brightening here, and these are the signatures of CMEs, which shows that CMEs is propagating from higher dense or the lower atmosphere of the sun from the higher height with some speed. At the third image, you can see the example of type 4 radio burst. Type 4 radio burst is associated with the high activity of solar surface, and it gives you a very intense brightening at higher frequency ranges. At the bottom image at the right side, you can see the example of type 1 solar radio burst. Type 1 solar radio burst are very fuzzy signatures which covers a wide range of frequency, and it can be usually observed during the high activity period of solar activity. Factor influencing solar radio burst can be characterized into several key aspects. These factors plays an important role in shaping the characteristics, occurrence, and the properties of the solar radio burst. Most major factor is solar activity. Solar radio bursts are closely linked to the solar activity level. Flares, which are intense release of energy in the solar atmosphere, are often associated with the radio burst. The magnitude and intensity of flare can influence the strength and duration of radio burst emission. Additionally, other solar events such as coronal mass ejections, eruptive prominence, and the active region can contribute to the occurrence and properties of solar radio burst. The other major factor is magnetic field structure. Magnetic field configuration of the sun's atmosphere, particularly in the region where the flares or the eruptive events occurs, which is known as active regions, can impact radio burst emissions. Complex magnetic structures such as magnetic loops, magnetic reconnection region play a role in the acceleration and propagation of particle involved in the radio burst generation. The interaction between the accelerated particles and the magnetic field influences the emission characteristics of radio burst. The third factor is particle acceleration. The acceleration of energetical particle is a crucial factor in the generation of radio burst. Solar flares and other eruptive events are known to accelerate electrons into ions to high energies. The presence of a strong electric field and magnetic field gradients can lead to the acceleration to particles along magnetic field lines. The properties of the accelerated particles, such as their energy distribution, abundance, and the trajectories, influence the spectral and the temporal characteristics of radio burst. The fourth major aspect is plasma condition. The properties of the plasma in the solar atmosphere, such as its density, temperature, and the composition, affect the propagation and amplification of the radio waves. Plasma instability and the wave particle interaction plays an important role in the converting the energy of the accelerated particle into the radio emission. The plasma condition can determine the influence of these processes, shaping the observed properties of radio burst. The last but not the least is the observation perspectives. The observation perspective of the from the Earth also affect the characteristics of observed radio burst. Factors such as position and orientation of the observing instrument, as well as the sensitivity and the frequency ranges of the observations, can influence the detection and the interpretation of solar radio burst. Observation from the different location and the instruments provide complementary information about the properties on and the special distribution of radio burst. So, in the conclusion, understanding of the factors influencing the solar radio burst is crucial for the interpreting their properties, in investigating their underlying physical process, and the establishing connections with their other solar events. So by studying these factors and their interplay, scientists can gain insights into the complex dynamics of the sun's atmosphere and improve our understanding of the mechanism driving the solar radio burst. Now you understand that solar radio bursts have a significant role to understand the different phenomena of solar physics. The study of solar radio bursts contribute to our understanding of fundamental solar physics, the mechanism of energy transfer and release, and the dynamics of sun's atmosphere. They can also serve as an early indicator of solar activity, providing valuable information for predicting and mitigating the impact of space weather on Earth's technological infrastructure, communication system, and the satellite operation. Hope with this training module section you will be able to identify and classify different type of solar radio burst from the observed data from your own installed Sunrise JRL antennas. If you still have any doubt, please reach us out with your questions to our website. Thanks for your attention. For being updated, follow us on our social media platforms. See you in the next module. Bye-bye.